Here's our first example of how we work with projectile motion. This is again motion in 2 dimensions. And our first example has somebody on top of a building 50 meters high and throws out or shoots out a projectile at 20 meters per second horizontally out. So how far will it go before it hits the ground? What's the range, or what is x equal to when it hits the ground? The way you usually I say, not always, but usually solve these types of problems is you want to figure out how long the object is in the air. So we start out by trying to find time in the air. And you do that by using this equation. Again, remember that the time in the air typically depends only on the vertical motion. So we use the equation y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. This equation should allow us to find time. So let's solve that equation for time. Our final height would be 0. Our initial height is 50 meters. Notice I will leave out the units to make the equation cleaner and easier to work with. Our initial velocity in the y direction is 0 because we do not throw it downward or upward. We simply throw it straight out, so it has no initial velocity in the y direction. So this is plus 0. And then, of course, 1/2 times g. Since g is a minus 9.8 meters per second squared, this is minus 4.9 times t squared. And we solve this equation for time. Notice if I move this term to the other side, it becomes positive. So 4.9 t squared equals 50. Divide both sides by 4.9. And we get t squared equals 50 divided by 4.9. Because here the 4.9's cancel out. And of course, then we take the square root. And we get 50 divided by 4.9. And of course, the units will be seconds. And of course, I need my calculator for that. So 50 divided by 4.9. And then we take the square root. And it looks like it is 3.194 seconds. Now, of course, I added a few extra numbers, significant figures that are not really significant, because I only had numbers to 2 significant figures. So this prevents me from getting a round-off error on an intermediate calculation. So secondly, now we need to figure out how far the object travels. So now we need the very same equation as this in the x direction. So I have x is equal to x sub naught plus v sub naught in the x direction times time plus 1/2 a in the x direction times t squared. Now notice in this case, since we assume x sub naught to be right here at the starting point, we can call this 0. And since there's no acceleration in the x direction, because there's no forces acting in the x direction, that goes to 0 as well. And we simply get the equation that distance x equals velocity times time. So that's where this equation simply is derived from that original equation. So all we need to know is the original velocity in the x direction, the time which we calculated here, and we can figure out the distance. X is equal to 20 meters per second times 3.194 seconds. And so x in meters will be 63.9 meters, or 64 meters, rounded off to 2 significant figures. And so that's the answer for that. So again, notice the strategy. Find time in the air first. Use this equation to do so. Once you have the time, then use this equation to find distance in the x direction. And that's how you do a project, an object or a problem like this.